Hello, everybody. I'm Queen, the host of PrefectLive. Today, we are excited to have Tim Liu, the head of product at BentoML, to talk about how to ship your models to production in minutes. Tim, welcome to the show.
Hi, Kuya. Nice to be here. Really excited to be talking about BentoML.
Yeah, I'm excited to learn some more about BentoML as well. I have been using this tool, but I think that I kind of get multiple pieces, but not all pieces together. So I'm excited to show our audience about your awesome tool and also learn some more about it as well.
Great. Sounds good. Want me to dive right in?
Yes.
All right. So, hey, everybody. Again, I'm Tim. I'm the head of product here at BentoML. BentoML is an open source project that helps to package your models and ship them to production as easily as possible. I promise I only have a few slides. It's mostly going to be a pretty hands-on presentation where I show you how you can save your models, build your machine learning service, and ship it to production in a variety of ways using our open source projects. So, like I said before, BentoML is an open source model serving framework that we built to help simplify the process of serving and deployment. The idea is that once you've trained a model, we make it easy to build a service around that model and to deploy it into a production environment. You can see our BentoML project on GitHub. So I'm going to talk through a few different benefits of using BentoML. First and foremost, what we're trying to build here is a unified experience for an ML developer who's developing a production service. So for example, we don't just help you build your API, we also help you save your models, load your models, package all of your dependencies. We have plugins for TensorFlow, PyTorch, XGBoost. I think there's about 20 or 30 in our documentation. Second, we believe that by creating a standardized process for serving and deployment, it will help developers be more productive as they create ML services. And you'll see later that because of our standard packaging, we make it super easy to deploy to lots of different cloud environments. And then third, because ML scales a little differently than traditional software applications, we provide purpose-built ML abstractions so that you can use to scale big models like Stable Diffusion or even graphs of separate models that work with your code, gluing them together without a lot of YAML. And then finally, we put a lot of thought into scaling your applications based off of different ML requirements. And like I said, we make it really easy to deploy into any environment and integrate with your CI/CD pipelines, which should help make your DevOps team very happy. All right, what is a bento? This slide is very special because Kuyen actually made this graphic. I think it was a while ago when she was posting something about BentoML and we noticed it on Medium. I think this is probably my favorite graphic of BentoML ever. I think it captures the essence of what BentoML does really well. So the idea is that in an ML service, you've got code, you've got models, pre and post processing logic, dependencies, configuration, sometimes static data sets, tokenizers, the list goes on. I've seen lots and lots of things packaged with an ML library. And the idea is that we take all of those things and really easily package them into one deployable unit, which we call the bento. In a nutshell, BentoML makes it easy to create and package your ML service for production. All right, let's jump into a demo. So we're going to be on the terminal a lot today. So I'm going to start with one of our most basic examples. It's a pretty good example of most BentoML workflows. So here you've got a training data set where you're fitting an iris classifier model. This code may run in your notebook or it may run in your orchestrator like Prefect if you're continually retraining your model. The idea is that once you've trained your model and you've got a model that you're ready to ship to production, you call the BentoML library, you say bentoml.framework.saveModel with the name and the model. So I'm going to run this real quick. So what we're going to get out of this training Python file is a tag for the model. Every time you call save, it saves under a different tag. That way, if your model is automatically versioned, if you need to go back to a different version or if you need to go forward, we've got a snapshot of the model that you just saved. So it saves into a local model repository. Whoops. Models. And here are all the models that I've saved into my local repository. We've got a little bit of information on them here, size, creation time. We actually save a lot more information. Get automatically underneath. And so here you can see that we're saving the scikit-learn version, the version of BentoML, the Python version. These versions are really important for reproducing your model when it's in production, because if you, for example, certain ML frameworks, you need to save it a different way depending on the version. But then in addition, you need to be running with the same version in production, or else you could be getting different predictions if you're running with a different version. And I'll talk a little bit about different ways that we can prevent getting bad data situations from happening. But what can happen a lot of the time, if you're running with a different version, you'll get different predictions and it won't actually fail, which is almost worse, which is worse than failing, because returning actual predictions makes it seem like it was doing something real when really it should have just failed because it was running with the wrong version.
I agree.
All right, so I'll show one more thing with the saved model. What we allow you to do here is not just save the model, but you can also annotate it with metadata. So for example, you can annotate it with the person who is training the model or comments about the context of the model. I've even seen people annotate the metadata with the features that they use to train the model. That way you can make sure to sync it with your feature store later, or the features that you're passing in. This is a really nice way to keep track of how your model was trained. We've got a lot of other options here, but the other one I'll call out just real quick is the signatures option. So sklearn, for example, we're calling the predict method in order to get our predictions. One additional feature that BentoML, that's a really popular feature with BentoML, is the ability to batch inputs automatically. So say you've got your API endpoint and you've got lots of inputs coming in. Behind the scenes, we actually concatenate those inputs and send them to your model, which really increases the throughput of your service. So instead of sending the inputs one at a time to your model, and for example, it taking 5 times the time to do inference, we put them all into one array and pass them in, and it takes slightly longer than one, for example. I talked a little bit about the local store, but that's only for development generally. You're saving the model that you think is the good model. When you want to get it to production, we provide a variety of different tools. So, for example, we allow you to export your model to either a local file or to S3. We implement a library called PyFileSystem, and they've got 20, 30 different plugins for uploading to Google or Data Lake or S3. So this allows you to push models to a centralized location, which allows you to share your models with other people. It also allows you to push your models to a centralized location for perhaps a CI/CD job to pick up and then ship to your next environment. All right, so the next thing I'm going to talk about is BentoML's serving architecture. I'm going to show a quick slide here. So this is what it looks like for most web frameworks scaling up. So there's a variety of problems with this for an ML use case. So when a typical web application scales, they replicate their workers because most of the time a web worker is very IO bound, so accessing a database or something like that. So it doesn't matter if you're replicating the worker itself. The problem with machine learning is that when you replicate your worker, you're actually replicating your model. And if your model is large, this is going to take up a ton of resources very quickly. And in addition, because you're replicating your model and your workers don't know about each other, you can't take advantage of features like batching. So we saw this and we decided to create a new ML abstraction called the BentoML runner. And so what this does is it automatically, and I'll show you the code in a minute, it's almost, you can barely even see it because it just introduces a very small tweak to make this architecture possible. So the code is still very easy to work with. What it allows is you to replicate the web workers, and then we coordinate all of the inputs from the web workers and batch the inputs to a single model. So if you've got transformation logic, for example, you can run your transformation logic in a web worker on CPU-based resources, and then you can run your inference on the model on potentially hardware accelerated infrastructure like a GPU. And then it also makes use of batching in between. So this architecture allows you to scale out a variety of different ML workflows. And I'll show you how this works. So here is a very typical bento. So this is the service code for creating a classify endpoint and running a prediction with the model that I just trained. So here at the very top, I call bentoml.framework.tag, and I call to the tag name. And I could call the tag directly, but in this case, I use latest just to get the latest model. And then I call toRunner in order to get the runner abstraction that I was talking about. And I'll talk about that in a second, a little more. So you pass the runner to an instantiation of the service, and then you use the service to annotate your API endpoint. So we pass the runner to the service so that when we're building the bento, it knows which models need to be pulled into the bento so that we're not pulling in all of the models from the local environment. So here you'll see the annotation of the classify endpoint. So one of the nice things about BentoML is we give you a lot of ML specific input and output types. So we support NumPy, we support pandas data frames, images. Of course, we support JSON and pedantic. I'll show you a little bit more about that in a second. Here, what we're doing is we're actually saying that we're going to be receiving a NumPy array. This is what the array is going to look like, and this is a sample, and it's going, based off of this sample and this D type, it's going to make sure that anything else, any kind of bad data or anything that doesn't fit this is going to be rejected. And then this is the classify data point, or sorry, excuse me, endpoint. We support both async endpoints as well as async inference. So async inference is an additional feature that BentoML implements. And the reason it's important to have both is if you're running your inference, or if you're running your transformation logic and your HTTP endpoint with async, you will, and your model on a separate machine or a separate node on the GPU, it's important that those two pieces scale separately and can act independent of each other. And then I think let's turn on this service. So actually, real quick, let me just show you a pedantic example. Here's a pedantic example, same idea where you're creating the runner and the service. And in this case, you create a pedantic class. This gives you validation on all of the data points coming in JSON. And you just specify the input is equal to this class, and then you get all of that validation for free. So the first command, once you have your bento file, sorry, your service.py and your model, as you say, BentoML serve. And here we're booting up the Bento server endpoint. And I'm going to take a quick look. This is a Swagger UI that we automatically generate for you based off of an automatically generated open API spec. So what it does is it looks at your Bento and it provides you a really easy way to test out your endpoints. So this is the classify endpoint that I just created.
Can you zoom in a little bit?
Oh, yep.
Okay, that looks good.
Great. So this was the sample that I specified on the endpoint. It gives it to me here automatically so that I could test it out, hit execute. And I think this is an iris classifier, so it's going to determine which type of iris flower it is. I think it's the first type. So this is all working well. This is a really nice feature for not just testing your service, but also showing to other people, demoing internally. So we have a few other endpoints here out of the box. These are some standard health check endpoints, and we also have a Prometheus metrics endpoint, which when you hit the Prometheus endpoint, we give you a whole bunch of standard Prometheus metrics so that if you've got a Grafana instance, you can graph like HTTP response times, CPU, memory. This is a really nice way to get a really good idea of what your Bento is doing. And about a month ago, we released a new feature where you can even create custom metrics here, where if you've got a domain specific metric to your Bento, you can add it here, and then you can track things like input or output drift. All right. So I'm going to go back to the terminal here. So this is great for local development. We've even got a reload option so that when you're changing your code and developing locally, the service will automatically reload as you change your code. When you're ready to load test it, you can do BentoML serve -- production. And so BentoML serve without the production flag, it runs one process and allows you to iterate pretty rapidly. What BentoML serve -- production does is it fans out the API servers depending on how many CPUs you have, and creates a couple of model processes where you're batching in between the two. So if you're running Locust or you're really trying to test the throughput of your service, you run it with -- production, and that will give you kind of an idea of how you're going to be serving in a production-like environment. So once you're done load testing and developing, you're going to want to build your Bento. And so building your Bento requires a couple different things. For example, you can specify exactly the libraries that you want inside your Bento so that it's not pulling in everything from your environment, so that your Bento can stay lightweight. You can specify exactly what Python files are going to be required. That way, if you're in a mono repo, it won't be pulling in all of the code. There's a lot of different features that we offer in the Bento file. For example, there's a Docker option here where if you specify your CUDA version, we'll actually not just install the right CUDA version, we'll actually pick the right Docker base image for you for that version of CUDA. If you've ever tried to assemble a CUDA image and deploy it by yourself, this should make your life a lot easier. BentoML build. And so what BentoML build does is it takes your model, your dependencies, and your code and brings it all together in a single Bento. And here's the Bento tag. So once you're ready to deploy your Bento, what you do, our basic way of deployment is by creating a container. BentoML containerize this. This isn't going to work because I don't have Docker on at the moment, but the idea is that you create your Docker container, and then you can push it to either, AWS ECS or Google Container Service, or Azure has a container service as well. It's a really easy way to ship a single unit to a fairly known environment where all it takes is a container. And I'll show one more thing real quick before I talk a little bit about deployment, and then I want to leave a little bit of time for questions. One of the examples that people often ask about is, how do you serve multiple models? We don't like the idea of using a ton of YAML in order to stitch your models together. We like keeping things really simple. So for example, here are 4 different runners. They're 4 different models. You put them into your service, and then you can call them with really simple primitives, async run with an async gather. And what this will do is it will fan out your inputs into all 3 of those runners and then bring them back together with very simple code, and then pre-process them later. And then a couple of our other projects allow for deployment into more complicated environments. So for example, AWS Lambda or SageMaker, really any of these, they don't accept a container just as is. You have to kind of change around the directory structure a little bit and create specialized endpoints. So once your bento is in this standardized format, we give you this tool called BentoCTL, and you're easily able to deploy your bento into these environments. And then for those of you wanting to deploy into Kubernetes, we provide Yatai, which is a Kubernetes native deployment solution. It's got a bento and a model repository built in, and then it's also got a lot of different ways to deploy bentos. So for example, what we do with runners is we actually create separate auto-scaling groups for your runners, as well as a separate auto-scaling group for your API server. That way you can allocate resources at a really fine-grained level for your inference versus your transformation or your HTTP serving logic. So I'll stop there. Thank you for listening in. And if you want to check us out a little bit more, you can check out BentoML.com or our blog, modelserving.com. And then those 3 projects that I showed you on GitHub. We also have a really great Slack community with a lot of people talking and helping each other build ML serving in production use cases.
Do you mind posting that? Can you send a link to me later? Actually, okay, I want to put that link in the description of this recording later so that you guys can access it.
Great. Sounds good.
Yeah, thank you for the presentation. Yeah, okay. So earlier when you talk about how metadata, how you can basically annotate a lot of things, like the developers who wrote the code, can you annotate anything? Like, can you put anything in that metadata, or is specific things?
Yeah, so the metadata itself is a key, it's key value, but it's mostly key string. So it's mostly for kind of flat metadata. But what we also provide is a way to include any given Python object. So we've got an attribute called custom objects, and that's for including things like vectorizers or tokenizers that go additional features that go along with your model.
That's very cool. And I think another thing you mentioned in the presentation that is very cool is that, I guess I kind of know this, but I don't think about it too much. And I know that a lot of data scientists don't think about it too much, is that different version of a package can result in different outputs for a prediction. So I think that the fact that you put the version of the packages inside each of the model version is very cool.
Right, right. And like I was saying before, it's sort of a bad thing. It's worse that you receive values at all rather than just breaking, because it kind of makes it seem like it tried to predict something.
Right.
And it makes the people who are calling your API a a little bit more confident that it was a real prediction, and that's really bad because you have no idea what it's actually returning to you. And so,
Right.
we add in ways to audit your data, like I was talking about, pedantic classes or shapes of the NumPy array. And then we also, in addition, make sure that we use a good dependency for your model.
Mm-hmm.
We also allow you to overwrite that if you want as well. Some people don't like that you're inferring the version. Some people know the version that they want for sure. So we allow you to pin it to a particular version as well.
So I'm curious, how do you guys infer the versions? Do you just uh, read from a requirements.txt, or do you kind of like take the latest version of the package?
Oh, I think each package, I think each package has probably a similar way to look at the version. I think it's just torch.__ version. And that's what we're saving based off of the environment that it's saved in. But
Right.
if an ML package is different, then we save the version a different way. That's what I was pointing out when we say BentoML.framework.save or load model. Underneath, what we're doing is we're saying, okay, is it this version? Because this version we have to do it this way. In this version we have to do it this way. PyTorch and TensorFlow, for example, are more complicated ones between versions. You have to be saving the model and loading the model a very different way depending on which version you're using.
It makes sense. Talking about the types of model, which packages that you support? From what you said, it seems like scikit-learn, PyTorch. What else do BentoML support?
Yeah, I think we support about 20 or 30 different packages. Our community and us, we're constantly adding those in based off of what we see as popular ML frameworks. XGBoost, PyTorch, Onyx. I think on our documentation page, we specify all of them. A popular one is MLflow. For example, a lot of our users use MLflow for experiment tracking. And then when they do create a model that they like, then we have a whole document on how to import out of an MLflow registry and then make a bento out of that model. And we make it really easy. I think it's the syntax is bentoml.mlflow.import model, and then you give it the URL for the model in the repository, and then you can same workflow after that where you build your service and then you bento build and containerize.
Right. That's cool. One thing that I want to point out to the listeners here is, I guess, Tim, your presentation, it shows a lot of cool features, and I really like that. I also want users to know that if they just get started with BentoML, it's very easy. Do you mind show kind of like your first Python script that you show how to for saving the model?
Sure. Let's see. This one right here?
Yeah, so basically you just need one line of code to, save the model and version the model and have its requirements being saved and its metadata, I assume. So
Right.
that's pretty cool.
Yep. And so, for example, I think the way that you would do it in Prefect is if you were retraining your model in a job. Sometimes people like to create scheduled jobs for retraining. This is the way that you would save it, and then you would push it and build your bento after you've saved your model.
Right, that makes sense. I assume this would be kind of like a task inside a trend flow if you are using Prefect.
Right.
Yeah, I think that's the end of PrefectLive. It was a great presentation. Thank you for showing us BentoML, Tim.
All right. Thanks, Kuyan. Thanks for having me.
Yeah. Bye.